Hello everyone, welcome back again. And this is the second episode of our series where I, of course, you can say kind of teach you to think independently. And of course, we are currently dealing with the Indian Mathematics Olympiad of the first stage. At, IOQM. And of course, we solved around six problems. Some people were commenting that, of course, positive feedback was, much there. And, the views also were, larger. And of course, people appreciated it because, of course, it's something you can say new to them. Not be new. My teacher also does that, but the thing is, it's not very expensive. Uh, right. So my aim is to show the real beauty of math to everyone. Right. People hate math because they think that it's all about practice, and in math something drops from the sky and all those things happen. But my aim is to show you that it's exactly not it. It's exactly the opposite of it. How you think fundamentally and how you actually approach a genuine problem, right? So with that being said, let us start the video. One thing, see, I am not providing here providing you the solutions. I'm discussing them, like discussing in the sense that how can you approach, how can you as a student, how can you think about this, let's say particular manipulation, or let's say particular, let's say you construction or something like that, especially in geometry. How can you think for yourself? Like if someone external comes and tells you that okay, do this, you will see, and okay, in no world will this thought come to my mind. But it will, only if think deep enough. And that thinking deep enough is not in our conditioning, and we have to you know either get some external guide or develop thinking for ourselves. So that's what I'm doing. I'm you can say kind of acting like a mentor, or mentor are just the usage of mentor has just been, what can I say, just does not hold any significance. In every now and then, each and every people will become a mentor, especially in currently you go out and you will find someone or the other giving you advice. But rather, let's just start this video, and let's see how many problems we can do. Of course, very much excited again, because this type of problems hardly we solve, right? So let's start. So let's start the second problem, right? So uh, let's see what it tells us. Okay. So quadrilateral has four vertices A, B, C, D, and we want to color each vertex in one of the four different colors: red, blue, green, or yellow. So that every side of a quadrilateral and the diagonal AC have opposite and have ends endpoints of different colors. Okay, and how many ways we can? Okay, so first you need to understand what the question is telling you, right? So let's just consider a general random quadrilateral. So it need not be any square or something like that. It can be any random shape. Let's say A, B, C, D. We are just numbering in cyclic order. Now we have been given that we have four different colors, right? So red, blue, green, or yellow. So we have four different colors, and again we have been told the main thing which we have been told. Let's say the thing which we have been restricted with, because see, if there were no restrictions, then how many possible ways would be there? See, A can have four different colors, B can have four different colors, C can have four different colors, and D can also have four different colors. So what would the total number of ways of selecting the colors? 4 into 4 into 4 into 4, basically 4 to the power 4, right? So, however, there are some restrictions have been imposed. Why? Because of course, for 4 into 4, why we can't exactly tell, but maybe one approximation I can say that 4 to the power 4 is a large number, but not of course very large. But I think whatever, for whatever reason, we have been given some restrictions, and they have told us that, let's say if A is red, if A is red, then B cannot be red, D cannot be red, and also C also cannot be red. Why? Because they have told that the diagonal AC have different endpoints. However, see, it is not the same for BC. If BC is yellow, sorry, if B is yellow, then D can be yellow. However, if A is yellow, she should not be yellow, right? So that is a thing to keep in mind in case you forget. It's just the restriction is for just for AC. So let me just draw the AC diagonal so that no confusion exists, right? So let's just, yeah, there we go. So now how can we approach this problem? Now take any vertex, right? Let's say we take the vertices A, vertex A, right? So vertex has how many choices? There are four different colors. Similar to this. See, if there are two different pens and I want to choose any one of them, how many ways I can choose? Two, right? Either I will choose this pen or I will choose this pen. So there are total two ways, right? So if A has, A has to choose one color out of the four different colors. So how many choices does A have? Of course, four. It's just the free and no restriction has been imposed upon. Just the free vertex. So A will have four choices. And the immediate next neighbor, D, how many choices will he have? Will it have? See, it cannot be it cannot be the color which that has been assigned to A. So for D, there would be only three possible colors. So why three possible colors? Let's say A is red, then D can be anything but not red. D can be green, D can be blue, D can be three colors have been given: red, blue, green, or yellow. Yeah, so blue, green, and yellow. D can be blue, green, or yellow, but it cannot be red. So how many choices again for D? Three choices. Can you tell me how many choices there are for C? Now, some people might make the mistake that okay, see D, there are total four colors, and D, this value, this vertex C should not have the same color as vertex D. So again, there should be three choices. However, that's where you miss the part, right? Because the vertex C should not also have the color of A. So there are two restrictions. It cannot be the color of A, it cannot be the color of D. So two colors already gone. How many colors left? Out of four, two gone. So two only left, right? So can you see that C will have only two choices, right? D will have three choices. Why? Because only one color has been used in A. But for C, it cannot be either the color of D, it also cannot be the color of A. Hence, there will be only two choices. Similarly, can you say how many choices will B have? Again, two. Why? Because, see, ideally, if this pattern was followed, then this should have been one. If it was given that B and D should not, B and D should also not have the same color. However, it's not given that. We have been told that uh, the color that has been assigned to A and C cannot be that of B. So there are four colors. Again, two colors gone. So how many colors are left? Two. So how many total ways? Just multiply. 4 into 3 into 2 into 2. 4 is a 12, 24, 48. Total 48 ways. Right. Uh, if you can't understand, then in this way, we have another way. Why worry? There's just so many ways to explain this easy stuff, right? So again, take an independent vertex. Let's say A has four ways. So let's say we assume this. So how many ways can C be filled up with? Three ways, because it cannot be the same color as of A and C. Again, D cannot be the color of A, D cannot be the color of C. Two choices here again, and also B cannot be the color of C, and B also cannot be the color of A. Again, two choices. See, whatever way you do, just multiply and you will get the same answer. 4 to the 8, 8 to the 24, 24 to the 48. Same answer as before. So, I hope you understand that after how, especially the restrictions, change the answers, right? So, it was again a very easy problem if you see it. Just avoid the error which I told you, because that's really very prominent people make, because they tend to forget that A and C should not have the same color, right? So that was the thing which I wanted to tell. So question number seven discussed. Let's now move on to question number eight. So, the eighth problem states that we have two real numbers. The sum of two real numbers is a positive integer n. The sum of the squares is n plus 112. Find the maximum possible value of n. Right. So, let's just first write what they have given us. So, consider any two real numbers. Let's say a plus b is it gives equal to n. So, now see, a plus b is equal to n. N is an integer, but there is by no means you can say that a and B are also integers, right? Consider 5 by 2 and 7 by 2. Add them up, what do you get? 12 by 2, basically 6 you get. But neither 5 by 2 nor 7 by 2 is an integer, right? So, this notion is a wrong notion that arises in people's mind, is that they think that if the two numbers they add up to integer, then the two numbers are also integers. So, it's not necessary. So, a plus b is equal to n. In two real numbers, we have taken a and b, right? So, and they've also given that the sum of the squares is n plus 112. So when been given that a square plus b square is equal to n plus 112. Now, now tell me how will you proceed? Can't you just directly see that you have been given a plus b? You are also given a square plus b square. What is the very next thought that comes to your mind? Of course, using a plus b whole square, square both sides, right? Just square both sides and see what you get. That's the most obvious thing that will come to your mind, because a plus b is given, a square plus b square is given. Just square it. So when you square it, you will get a square plus b square plus 2ab, right? So basically, what you will get is n plus 112 plus, let me please ignore my handwriting again, lack of stylus, plus 2ab is equal to n square, right? So you got this equation. So how did we get this? It's just simple maths. Like simple maths means simple common sense. If you see a plus b and you need to create a square plus b square, so you just square a plus b so that the a square plus b square term is created, right? So now when you get hold to this equation, that n plus 112 plus 2ab equal to n square. Now, can you see it's kind of like a quadratic in n? If you can somehow find the value of n, then that your problem would be finished. Can you also see that it has been asked the maximum possible value? That means the value of n should lie between a particular range, right? So if the value of n lies between a particular range, then can you understand or can you realize that we have been given two numbers a plus b, and maybe to find some quadratic or some inequality in n, we of course need to get rid of this 2ab term. That means we have to relate somehow n, sorry, once again, let me just rub it off. Yeah, so now somehow we need to relate this 2ab term with n. How can we do that? So for the people who know that the thing called AMGM inequality, it's not necessarily you know it. I will also tell method two, that how can you do it without knowing it, because the thing which we would be using, it would be just like the definition of AMGM thing. But for those who know it, let me just do quickly for them. So basically, how does the AMGM thought even trigger into mind? You see two numbers a plus b, and the sum is given, and you need to deal with some range because it has been given the maximum possible value of n, and you need to also deal with the product. So that's how you get the thought in mind that a plus b, which is basically am, is greater than equal to gm, which is basically root ab. So now what you do is you just square both sides, because you need this 2ab term, right? So of course, a plus b again. Now how can you relate it with n? A plus b is equal to n. So n by 2 is greater than equal to root ab. So yeah, so root ab. So now I just square both sides. Square n square by 4, n square by 4, and it would be just ab. And now we need to find 2ab. So just multiply 2 on both sides. Can you see that the value of 2ab, the value of 2ab should always be less than equal to n square by 2? Can you see that the value of this term 2ab is always less than equal to n square by 2? How did we do this? Again, by just using AMGM, right? So, of course, I will also tell method 2. Just don't, close this video and say, no, no, I don't know AMGM, then how can I do? I have an alternate approach. Of course, we will again end up with the same kind of thing, same set of equations. However, alternate approaches should also be kept in mind, especially if you don't know AMGM right now. Right? It's a very important concept. You should, learn it. But of course, if you don't know, then also there is a solution. But for current, just wait. So, can you see that this value of 2ab should always be less than equal to n square by 2? Right? So the maximum value of 2ab can be n square by 2, right? So can you realize this? The equality sign will change. The equation will become n plus 112, n plus 112 plus 2ab. Instead of 2ab, just write n square by z. Just write, sorry, n square by 2. I just misread. Again, I'm a bit tired, so please ignore my misreadings. I just again misread that as n square by 2. So can you realize that this value will be greater than equal to n square? The equality sign changes. Do you know why? Let me just zoom out a bit. Right. So the reason why it changes is that, see, the maximum value of 2ab was n square. So in general, the value of 2ab will be less than n square by 2. So if I substitute in place of 2ab as n square by 2, then we will get the value which is more than this n square. So let's take an example. I know you might get confused in this, because I also got confused with this first. But let's take an example. Let's say the value of 2ab is 3, and let's say the value of n square by 2 is, let's say, some 6, right? So let's say 2ab, which of course is less than 6. So basically 3 is less than 6, right? So if uh, 3 is less than 6, can you realize that if I put n square by 2, basically if I put 6, then see what I have told, that n square by 2 is equal to 6. So n square would be 12. Can you realize that it would be 12? Why? This of course clearly, can't you see? Add them up, and n is again what I think m has been given a positive integer. Yeah, positive integers. Can't you see it's of course greater than 12? Right. So if you might get confused in that, no worries, no worries. Again, I will again just once more explain you. No issues in that, right? Because of course it's a bit confusing thing. I previously, when I was recording this video, I messed up the sign, and also the audio was not proper. So again, I'm doing this the second time again. So uh, no issues there. So the thing again, let's just come again, right? So 2ab. So the maximum value of 2ab is n squared by 2. However, in general, 2ab is always lesser than equal to n squared by 2. Now, if you put the maximum value of n squared by 2, then we will get something. You know, if we just did 2ab, and if say, let's say, what would be the normal maximum value? The normal maximum value would be when 2ab equal to n squared by 2, right? That is the maximum value of 2ab. Now, when I input the maximum value of 2ab, generally the 2ab value, if I add it, the value becomes equal to n square. However, if I add the maximum value of it, then it would be greater than equal to. Why? Because this is the maximum value. Now this becomes the minimum value, right? Previously it was the whole result itself. Now it became the minimum value. How? Because you added what can I say, greater number to it. I know you might get a bit confused, so let me just use a bit of Hindi, right? So I hope you will not mind. सो तुम्हें बेसिकली बताना क्या चाह रहा हूँ कि पहले ये थोड़ा मिटा देता हूँ, ठीक है? तो सो फिर से देखो, फिर से लास्ट टाइम पहले बार भी ये बोला था, बट ठीक है, एक बार हिंदी में समझा देता है, ठीक है? नो प्रॉब्लम्स. सी, वी हैव बीन गिवन दैट दिस प्लस द वैल्यू ऑफ 2ab is equal to n square. See, the value of 2ab is maximum when it is n square by 2, right? So all the rest cases, in the rest of the cases, the value of 2ab is always less than equal to n square. Sorry, n square by 2. So the minimum value of the maximum value of this whole 2ab term, or rather the maximum value of this whole term would be this. Can you see? And generally what happens is that this term will remain equal to n square. But if I use the maximum value, then either it would remain equal to n square, or it will become more than n square. तो देखो, अगर 2ab के बदले में अगर 2ab का जो वैल्यू है, ठीक है, वो n स्क्वायर बाय 2 से छोटा है, राइट? तो जनरली वो n स्क्वायर बाय 2 से छोटा रहता है, तो अगर हम 2ab रख देते हैं तो वैल्यू n आ जाता है, मतलब n स्क्वायर आ जाता है राइट हैंड साइड में. पर अगर हम 2ab का ही मैक्सिमम वैल्यू दे दे, मतलब 2ab को ही पूरा दे दे, मतलब मैक्सिमम जितना हो सकता है उतना दे दे, तो तो एन स्क्वायर बाय 2 से तो ज्यादा ही आएगा ना. सॉरी, एन स्क्वायर से तो ज्यादा ही आएगा ना, क्योंकि देखो प्रीवियसली ये जो वैल्यू था, ये एक पर्टिकुलर नंबर से कम था, लेकिन एन स्क्वायर के इक्वल था. नाउ ये जो वैल्यू है, ये मैक्सिमम हो गया, और जब ये वैल्यू मैक्सिमम हो गया, तो इसका जो वैल्यू है, ये भी इसका इसका इस एक्सप्रेशन का मिनिमम वैल्यू हो गया एन स्क्वायर, क्योंकि ये तो मैक्सिमम वैल्यू ऑफ 2ab है, राइट? तो 2ab इससे ज्यादा तो हो ही नहीं सकता. बट 2ab जनरली एन स्क्वायर होता. अगर 2ab रहता तो सिर्फ 2ab रहता तो एन स्क्वायर होता, बट हमने 2ab का मैक्सिमम वैल्यू निकाल दिया, मतलब बैठा दिया, तो फिर एन स्क्वायर हो गया ना, क्योंकि इनइक्वालिटी का साइन चेंज हो गया, राइट? सो I hope it's clear again that the minimum value of 2ab is n square by 2. I know I'm like kind of over explaining, but really it's a bit of tough to grasp. But I am trying my heart and soul to get this into your mind. That's why I'm repeating it again and again. That see, if the value of 2ab is less than equal to n square by 2, so generally this equation holds true. However, if I apply the maximum value, if I put the maximum value of 2ab, then the equation would be either greater than equal to n square. Why? Because this value is inherently less than or equal to n square by 2. However, if I directly put the maximum value here, then this whole equation will have the minimum value n square. How will it have the minimum value n square? Because from this condition, again, that's it. Now, that was all that was required. Once you reach to this stage, you just bring this to the other side, and you will get a quadratic, clearly a quadratic in n. So what I think you will get is you will get n square, and if the 2 goes there, minus 2n minus 1024 minus 1024 less than equal to 0. So just get this equation, you will just easily get this equation and equation in quadratic in n, and just solve them, and you would find out that the value of n should let's see what are the roots. The roots are I don't know, especially let me just check a bit. Okay, so let me just find out the roots and then I'll tell. Right. So I found out the roots. So the value of n should, lie between minus 44 and less than equal to 46. Now, of course, if you just factor it out, and then also you will get the same answer. Just factor it out. Just simple factoring it out. Sorry, this would be 2024. Just factor it out and you will get the answer. Right. So it's again really really simple question, and you can easily do it. Now, one more thing is that how can you solve this equation of n square minus 2n minus 2024 less than equal to 0? This also we will come to. Should I tell it now or should I tell it later? Okay, so let's just keep this thing for later, that how exactly from this stage we are coming to this problem. Because I know after this 2ab thing you might not be able to grasp properly, because maybe my explanation is a bit poor, but I hope you get the essence. That's the feel. If you can get the feel, that's it. See again, let me just try one more time. That so the value of 2ab is maximum when it is equal to n square by 2. So generally, this whole equation n plus 112 is plus 2ab equal to n square. This holds true. However, if I put the maximum value of 2ab here, then this equation will take a turn. So the only possible, the equation will always be greater than or equal to n square. The y equal to, because at maximum value 2, who knows if 2ab equal to n square by 2. If that is the case, then of course the whole thing would be equal, right? So you are not just putting that 2ab is equal to n square by 2, you are also changing the inequality sign. Of course inequality sign will change, because initially if the added value was to be less than n square by 2, then the equal to n square, that identity, or that what can I say, that inference held true. However, if I am directly putting the maximum value of 2ab, then the whole equation should of course be less than equal to n square. Less than equal to n square means, sorry, the whole equation should be greater than equal to n square. Why? Because 2ab is maximum value. If the value of 2ab is maximum, then of course the whole value will be greater than equal to n square, because the maximum value, because the minimum value will of the equation will now become n square, right? So that's the thing. So I hope it's clear to you. Really, again, if you again, if you're facing still facing doubts and queries regarding this, please just let me know in the chat box, and I will try to comment section. I will again try to make a separate video on it. And also, I will also make a separate video. Currently, it's not possible for me to again tell you currently that otherwise you will just get bored, right? So x minus alpha into x minus beta. If you just factor out, can you realize that it would be some n minus alpha into some n minus beta uh, less than equal to 0. So how from here, how do we actually end up with this? I will also tell you that, right? So in case you can't find it out, so no issues there. Again, that's really simple. But let's just skip it for now, right? Today my aim is somehow finish those 10 the up to question number 10, that is basically all the 2 markers, and then we can directly start off with the 3 markers in a new video. So let me just clear this off, and we'll start with problem number 8. So moving on to the ninth problem, right? So again, what we have been given is that the four sides and a diagonal of a quadrilateral are of lengths 10, 20, 28, 50, 75, not necessarily in that order. Which amongst them is the only possible length of the diagonal, right? So let's just draw a quadrilateral with one of its diagonal, right? So one diagonal is given, so let's just draw that. So let me just draw respectable diagram. So let's say this is a diagonal which we have been given. Uh, Is there any option to do some straight line, or rather just forget it, right? So please, that's a straight line, so please don't confuse with it. Right, so we have been given that the four sides in a diagonal of a quadrilateral are of lengths 10, 20, 28, 50, 75. Amongst them, which is the only possible length of the diagonal, right? So how can you find it out, right? So the thing is, again, can you see the after seeing this diagram, what does the thing that triggers you? And also this diagonal on those, what do they actually mean by the only possible length of the diagonal? Can you see that it's similar to that previous kind of problem which we tried to do? Which one was it? Which one was it? Okay, yeah. So how many isosceles integer sided triangle? Basically, again we use the same property, kind of same property, that the sum of two sides is greater than the third side. So let's say this side is A, this side is B. Let's say this is C, this is D, and let's say the diagonal is some K, some E. Let's say the diagonal is E. Let's say it's E, right? So can you see that A plus B would be greater than E, and also C plus D would be greater than E. So whatever the two sides we are taking, that should the diagonal should be greater than that. The diagonal should be less than that, right? So let's say we take two sides. Let's say we take 10 and 20. Then which of the following is possible, right? So see, if you take, let's say first take 10 as all combinations, then we'll take 10, 20 all combinations, then 28 all combinations, and all those. So let's say A is equal to 10 and B is also equal to 20. Let's say A is 10, B is 20. So add them up, so that becomes 30, right? So if that is 30, then what is the possible length of diagonal? Only 28, right? Because 28 is 28 is what, greater than 30, less than 30. 50 and 75 are greater than 30, so they cannot be the answer. Let's say we take 10 and 28. So 10 and 28 would be 38, and if 10 and 20, 10 and 28 becomes 38. Can you see that what would be the sum of them? The sum of them would be 38, right? So the diagonal should be less than 38. So less than 38 is only one possible, right? That is 20. So 20, and the rest two sides would be 50 and 75. So just add them up. Wait. I think I'm doing a mistake. Let me just rub it off, and let's see again. Wait. Well, I think I just messed up again. I'm a bit of tired, but please, no excuse for that. Just wait. I'll just confirm, and I will tell you. Let me just think a bit for 2 minutes, and then again I will tell you. So yeah, no problem. We were going in the same direction, right? So we were going in the correct direction. So whatever be the length of the diagonal, let's say it's E, right? So A plus B should be of course greater than E. That is the condition number one, and C plus D should of course again be greater than E, right? It's just the sum of two sides of the triangle is greater than the third side. However, that's again a property of triangle. I know, again, it's just crowding your mind that so many properties. How will we actually remember? That especially this is a problem in solving exam papers, that I cannot just directly teach you fundamentally, because some things, especially if I solve them, then I would need an entire video covering each and every concept to connect each and everything. So I don't think people would be much interested into that. But if you are, please let me know. Then I would be, kind of motivated for that. Motivated in the sense, I would, you can say, if it is on demand, then I can do. But because of course it requires extraneous efforts on my end, and of course to view also, again, people are required. But again, but let's currently come to the current problem. So this is one set of condition, and also there's another condition, is that the value of the value of E should be greater than the difference of the two sides, right? So the third side should be greater than the difference of the rest two sides. So that is also a thing you need to keep in mind, right? And also E is again greater than equal to why mod, because I don't know whether is more or B is more. So of course I'm taking the magnitude. So that's the point of applying the mod, the modular symbol. So that's the thing. So E also has to be greater than, the difference of the two sides. So let's consider each and one by one all the diagonal lengths, right? So let's say the length of the diagonal. Let's start with the maximum. Let's start with the 75 one. Okay, let's say the length of the diagonal is 75. So can you see how easily this condition gets violated? Just take 75, add 50 and 28. How much you get? You get 78, right? You get 78. Right. Okay. So 75 is a diagonal. So just okay. So what would be the what can be the sides? 50, 10, 28, and 20. Right. So the maximum possible value is what? 50 and 28 you take together. 50 and 28 you take together. How much you will get? 50 plus 10 is 60, and another 20. Okay. So 78. You will get 78. So of course this condition is valid, but is this condition is valid? What is the rest two lengths? 20 and 30. Add them up. 30. So of course 75 cannot be possible, because see, if you take, see, 50 is the maximum. So if you take 50 with 20, you will get 70. Or if you take 50 with 10, then again you will get the sum of two sides at 60. Then, which of course is not greater than 75. For even the first option to hold true, you will take 50 and 28. That will make 78. The first becomes true. However, if you do that, the raised 2 becomes just 10 plus 20, that's 30. So 30 is of course not greater than 75. So then that means 75 cannot be the length of the diagonal. So we could just, for 75 one, we could just, identify with only the sum of two sides is greater than the third side, that thing. For 50, number 50, let's say we assumed 75, let's say 50. Let's say if E is 50, right? So if E is 50, then again take two sides, I guess. Yeah. So uh, okay, so let me just write down. Okay, so 75 cannot happen. No. Okay, so let's say 50 is the diagonal. So what can be the possible things you can take together? See, can you see if you take 28 and 75 together? Of course, that would be greater than 50. However, if you take the raised two sides, 10 and 20, that would be again become 30, which is of course less than 50. So that we cannot take. Let's say we take another combination. Let's say we take 20 and 28 and 75 and 10. So 20 and 28 is what? 48. So that condition again is just, bullshit. I mean, it holds false. This thing only holds false, right? So however, you will say, let's say take 20 and 75. First condition, this one is satisfied, but 10 plus 28 is how much? 38. 38 is of course less than 50. So this condition is again failed, right? So 50 also cannot be the length of the diagonal, right? So 50 also crossed out. Now let's say 28. Let's take 28, right? So for 28, let's say, let me just draw a banner kind of thing, right? So let's say you take any two sides, 10 and 20. 10 and 20, of course. 10 and 20, 50, 75. Can you see both of them are satisfying? Can you see? Let's say if you want to take any other side, any other combination, let's say you take 50, 20 and 10, 75. Again, they're satisfying. Both of them are greater than 28. Let's say you take another one, 75 and 10, 20 and 50. Easily satisfying. So 28 is satisfying this condition. This condition. But we should not get so sure. We have to verify this condition as well. That it should be greater than the difference of two sides. Right. So what is the difference? Let's say if we take 75 and 10, what is the difference? Sorry, if we take the sides 10 and 50, what is the difference again? What is the difference is 10 and 50? Where did it go? Mm, just wait a minute. So, right, we were doing it correctly. So again, a bit of shock, because I thought I was doing it wrong, because again, a bit of tiredness is again, kind of a thing over me. But rather, uh, where we were, yeah, we were in this. Okay, so we were analyzing this 28 situation, and we saw that okay, a plus b and c plus d, this condition is holding true. However, when we are considering E, right, basically, which is basically the 28, see, we have to choose the sides carefully now. If we choose the sides as 10 and 20, and 50 75, then of course it's fine, because 50 and 75 the difference is 25, and 10 and 20 is the difference is again what the difference is just 25, right? 50 and 75 the difference is 25, right? So and the 10 and 20 the difference is 10, so of course both 20 is greater than both 25 and 10, so that's no issues. However, let's say if you take 75 and 10, then the difference becomes what 65, and if you take this then the difference becomes 30. So don't take this, take the side would be what can I say, 20 10 and 50 75, then this condition holds true, right? So that was the thing I got confused with. I was thinking that 50 and 10, if they if I subtract them, then of course I will not get this value of 28 which is greater than them. So if it has to be 28, then that much restriction should be followed, that this this is 10, let's say, and this is 20, this is 50, and this is 75, right? So that's the thing. That was the thing that was to be followed, which I missed a bit. I thought that if we take 75 and 10, then I realized that it not necessarily in that order, it can be in any order. So 28 works, right? For 28 all satisfied, right? So we don't exactly know. Of course it's telling that the only possible, and then 28 is working just fine. So of course I know your intuitive feeling on common sense will also tell you that yeah, 28 is the only right answer. But still we are now discussing, we just cannot, we are not doing cheap things, right? So let's say now the very next question is that let's say the diagonal length is 20. If the diagonal length is 20, see, first of all, again the sum of two sides, just see if it's valid or not. See, 20 is again some banner, take 50. See, for all of them this two conditions will satisfy. How? Just check, 75 plus 10 greater than 20, uh, 75 plus 28 greater than 20, 75 of course greater than 20, 10 plus 28 again valid, 10 plus 50 again valid. So each and every condition satisfies. So all of this both satisfies like it did for 28, 20, 28, right? However, if you come and look into this, let's say the side is what, 10 and 28, 10 28 and 50 75. Can you see the first one satisfies, because for the first one the difference is what, 8, the difference is of 8, or sorry, the difference is of 28. So that, oh no, so that also does not satisfy, the difference is of 28, and sorry, the difference is 18. So that one satisfies. Again, I'm just see, I am doing 10 minus 28 as 18, I am telling, right? Sorry, 10 minus 28 is 8, I am telling, but anyways, so that would be 18, right? So the difference is 18, so this one works. But see, 50 minus 75, the difference is 25, and 20 is less than 25, so these conditions become strong. Now you might be thinking, okay, that one become wrong, let's say take another one, 70 and 28, and 50 and 10. Can you see easily 50 and 10, 40, 40? So of course that's again wrong. So can you see for 20 also we will get no such solution. Why? This was satisfied by both 28 and 20. However, for 28 we found the case where this condition will all these two conditions also hold true. However, in none of the above scenario, if 20 is the diagonal, this holds true, because again, as I mentioned, take 10 and 28, then again the difference would be 18. Take 50 75, the rest two sides the difference would be 25, again false. Let's say if you take 70 20, again get again what, 55 greater than 20, so of course that will fall, right? So that's just wrong. So 20 also doesn't work. So now moving on to, if we take the value of diagonal as 10, so let's say that the value of diagonal is 10, let's say, uh, as we did for the previous ones. So now again, and what can I say? Not necessary to say, but it's obvious that again, if you take any other combination, then of course these two conditions will be satisfied. You take 50 70, sorry 20 50, 75 28, or any combination you feel like. This whole part, the some part, this satisfies. Now the main game is on the difference part, right? Again, if you did not understand, watch this closely. So now just take the sides, right? So let's say you take the sides as 28 and 20. So what would be the difference? 8. So 10 is greater than 8, so it's fine. However, again 75 and 50 would be the rest two sides. Take the difference. How, what would you get? You will get again 25. 25 is again less than 10, the same thing. uh, right, so let's say you will say that no sir, I will take 20 and 50. Then the first thing you are doing is wrong, because 20 and 50 is what difference is 30, again less than greater than 10. So this condition again does not hold true for 10 as well. The only possible diagonal length is 28. I hope it's clear to you why this is satisfied for both 10 and 20 and 28 as well. However, this failed. This was valid only for 28, and that too in a one special case scenario. So that can be that the case is there where the diagonal can be 28. However, if the diagonal is 10 or 20, then of course this subtraction part does not hold true. As I mentioned, maybe one holds true, but the rest two will not. Right. So that's the thing. Again, a very you can say deeply conceptual and engaging question. Engaging in the sense that you need to know first. Need to know this, and of course you need to analyze a bit for getting to the what can I say, the actual solution. But of course, it was considered an easy problem, especially people, they always the main thing was that, not because, see, if you already know all this, and if I was to personally solve, then it hardly would take me 5 minutes or maximum 10 minutes. Even 10 minutes for this question is too much, right? I think maximum, even if I just have to fresh start, then I would require 5 minutes, right? So I am just explaining this all so that you can think independently. That's the main point, right? So I hope this ninth question is clear. Now moving on to the last question. Last question not in the entire paper, but the type two. I mean, two markers. So after this, the two markers would be finished, and then from the next video, maybe we could start the three markers. But let's just first do the number 10 question, right? So let me just clear the mess which I've made here while drawing. So then we'll start the number 10. Right, so let's read the 10th question. What it says is that the age of a person in years, of course it's years, because if it's months, then we have to do a lot of more calculation. But the age of the person in years is 2025. It's a perfect square. Okay, okay. So let's say his age is some a square. Let's take a square, right? Let's say the current age, or person 2025, whatever they have told, right? So currently it's 2026, but this paper came in 2025. So let's just assume that the perfect square number which the person says was in 2025 was a square. His age in years was also a perfect square in 2012. So if his current age is a square, so what would be his age in 2012? So that's what, 13-year difference. So 13-year difference, what, 2025 minus 2012, 13 year, right? So a square minus 13, right? So a square minus 13 would be what, again some b square, right? So now realize that one thing you need to note, that a, b, and whatever variables this m will always be what, integers, because age is integer. How can age be 11.5? Now of course you will say that maybe months and all, but of course as it is mentioned that only years. So if it is like, let's say even one day before your birthday, then also you would be considered 11 years, right? So of course that is very absurd idea, but the thing is, I hope you get it, that this a and b and m and all those will be integers, right? It cannot be some real number. It is not explicitly mentioned, but it's just common sense, that how can age be integer or fraction? How can age be irrational, right? So that's the thing. So you need to keep this in mind, that a and b both are integers, right? So his age in years will be a perfect m cube after m years in 2025. Okay. So in 2025 his age is a square, and let's say after m years, so let's say after m years is what it has told is that it will be a perfect cube. So let's say the cube is c cube. Let's say the c and the perfect cube. C is again an integer, right? So determine the smallest value of m, right? So okay, we have to find the value of m. So now what we have been given? We have what we have in our hand. So right now we can't get any idea that how to find m. maybe we can find A, C, and B, individually, and then find maybe the value of M. How exactly do we approach, right? Now, see what we have been given. We have been given that A square. Let's just bringing these unknowns to one side. This is again just a common sense in the sense is fundamental idea that okay, bring all the unknowns to one side, and 13 is a good constant, so just send it to the other side. So just for writing sake, I am writing A square minus B square equal to 13. Now, of course, you are thinking that what to do. This very thing, this A square minus B square also triggers something in you that okay, A minus B into, let's say, A plus B. Of course, this again, whenever you see A square minus B square, you will think of this A plus B into A minus B, and you will think of it of let's say it's 13. You will say it's 13. Now, now you're thinking that how can we proceed? Of course, it's not kind of quadratic that we could directly just equate it to zero like we used to like we could in quadratic. However, after thinking for a moment and taking a bit of inspiration from which problem, I think it was this problem. I guess the perfect square one and this thing. I guess or no, not this. Mm, I guess this from the nine. I'm taking some inspiration, and after that, okay, yeah, taking from inspiration from this problem, right? I now remember that. Do you remember that you did h plus? Basically, I told you to try to create that r minus two term, right? You will sit for a moment and you will think that how can we actually approach this. Then you will remember that a and b are both integers. That means, and also 13 is what? 13 is a prime number. Just see, everything is falling into places. 13 is a prime number. So can you see what can be the possible and solutions? Either 1 or 13, or 13 and 1, because a and b both are integers. Why? Because they are ages have to be integer, right? So a and b and a plus b both are integers, so it can be either either a minus b is 1 and a plus b is 13, or a minus b is 13 and a plus b is 1. Now can you realize that this is not possible, this second case? Do you know why? Because a and see, a is greater than b. A is, of course, uh, undoubtedly greater than b, but a minus b is 13. Fine. If a minus b is 13 and both the quantities are positive, both a and b are positive, how can a plus b be 1? Of course, it's still if both the ages cannot be negative, so a and b are also positive integers. That also you need to keep in mind. So that means this case is also rejected. Can you see? Because a minus b is, if it is 13, then how on earth can a plus b be 1? Of course, that's again rejected. So the only possible case is that a minus b is equal to 1 and a plus b is equal to 13. Do you realize why? Simply because a minus b, see, a minus b is some, of course, some positive quantity, and a plus b is also some, of course, of course, it will be a positive quantity. Now, see, ages can't be negative. So if a minus b is 13, it's fine. But if a minus b is 13, how can a plus b be 1? So, of course, it's impractical, right? If a and b are both positive, right? So I hope you get my point. So now you have just two equations: a minus b equal to 1 and a plus b equal to 13. So from here, see, you can find the value of a. A comes out to be 7, and once you find out the value of a to be 7, clearly you just put the value of 7 here, and similarly, see, you can find even value of b. Value of b would be what? 13 minus 7, what would be it? It would be 6, right? So again, really really easy. Can't you see? B would be 6, a would be 7, right? So now, so what would be a square? A square would be 49. 49 plus some m. This thing should be a perfect cube, right? So now, finally, what we did, what we just simply use this common sense that a and b should be both positive integers, and 13 is a prime number, so we use that fact, right? And we reach this conclusion that okay, 49 plus the value of m would give us the value of C cube, right? So now what? And now the problem becomes really, really easy. Like you might ask that, how come it's easy? See, what they've asked us is they have asked us the smallest value of m. So what are the perfect cubes? One cube is one. See, m cannot be again negative, right? Because his age will after m years after m. Of course, how can m be negative? Just it's again common sense that it has been given that m years after 2025. So of course, m would be greater than what will I say? You can see from here also. You can see from here also, right? So it would be a perfect cube. C of course cannot be negative because C is the age we assumed, right? So of course age cannot be negative. So C cube, both of these are positive, and M also has to be positive because it is some after some years. So how can M be negative? How can be minus 2 years after 2025? Of course that's not possible, right? So M would be also positive. So what is the cube nearest to 48, 49, but greater? See, what is 1 cube? 1. 2 cube is what? 8. 3 cube is what? 27. 4 cube is, however, 64. Can you see that greater than 49, yet, minimum value of minimum cube that is greater than 49, yet uh, sorry, the minimum yeah, so the minimum value of m, minimum value of c, or rather c cube, which is greater than 45 and is also a perfect cube, right? So what would be just 64? It has been asked the minimum value. Let's say the next very next number, 5 cube. 5 cube is 125. So of course the m can be 125 minus 49 also, but it has asked the minimum value of m, the smallest value. So for smallest value will be what? 64 minus 49. So 64 minus 49 would be what? That becomes that. So what would 15? Yeah, 15. So I just take the answer. 64 minus 49 is just 15. So that's literally it. We have finished the 10 markers. Sorry, 2 markers. The 10 questions. I know it took a bit of time, but I hope you remember the thought process. You can gradually, as we move on to the further problems, then you will catch up on the thought process. Literally, it was one of the most easiest. Can you see just how did we? It's like common sense that okay, fine. Let's just bring variable to one side and another, and the constant to other side. And also this a square plus b square, it also triggers that a plus b into a minus b thing in my mind. So that's why I did that. Now, as soon as you read that, the very next thing that will hit your mind is that can I split? Because 13 is a prime number. And you will see, yeah, it's integer and a positive integer, in fact. So that's why you get only this case, you get the value. B was not even required, you did not even find B. Just A would have done. Found after you have found A, I just put the value in this equation which we found out, and then 49 plus m equal to 3 cube, and we have to find the minimum value. So of course it has to be perfect cube which is greater than 49 and has to be minimum also. So 125 is also a value of m, but it is not the minimum or the smallest value of m. Hence we take the value 64 and we get the answer as 15. So that's it. So I hope you enjoyed this 10 2 marker questions. Again, we have the 3 markers to come, which is of course much more interesting, especially what can I say? This problem, a combinatorics problem. Where did it go? Yeah, this is also very good problem. See, this is again you can say kind of made. This is very easy. This very easy again. This is also not much tough because it's just basic number theory. This one again, this combinatory stuff, I think I am also a bit of weak at combinatorics, but of course nothing to brag about that. But of course I need to also improve this combinatoric stuff, so maybe this combinators I will maybe skip it, but I'm not sure yet. But I hope you enjoyed this. Again, what we did 5 questions here, but I promised that I was feeling a bit tired and very exhausted today. That's why could not pick up much speed. But I am sure that it won't affect you much. I hope you get the thought process easily. If you found any part of the video confusing, especially I think I might not have been fully able to explain this is a question, the two AB thing. Then please let me know in the comment. Please, I will definitely make a separate video out of it and make all your confusions clear. Just list down the confusions and I will make it. Or maybe you can just email me whatever. If you have a different approach, that would be more easier to explain to the students. And of course, I will kind of shout out your name or whatever those kind of things. But I hope you really had fun because that was the main aim. And now we have to move on to the tougher problems in the next session. So please stay tuned for that, and I hope it was very exciting. And at some places I lagged a bit, so of course that will happen, but I will try to minimize it as much as possible. But of course, next video I may not be of math, maybe some other subject. Let's see. I'm not exactly sure, but for now, see you later and take care. Of course, bye.